Okay, what kind of triangle will always have three congruent sides? Who's got this one? Lola in the back, go ahead. Equilateral triangle, very good. Number 2, what type of triangle do we have? First, we're going to classify these by their sides, and then let's see if we can classify them some other way. Number 2, who's got that one? Unisa? That's an equilateral triangle. Is there another classification we can give this triangle that's not on its sides, not based upon its sides? Kalila? Yes, this is an acute triangle. And then there's a new word I want to expose you to. It has to do with the angles, and you could probably guess what this means. Equiangular. Who knows what equiangular means? Trinity? All the angles, all the interior angles are the same measure. So in this case, it would be 60 degrees, 60 degrees, 60 degrees. Okay? And who's got this one right here, number 3? Nathan, what type of triangle do we have here based upon the side lengths? This is an isosceles triangle. And then is there another classification for this triangle, Edipoji? This is an isosceles right triangle, yes. Over here we have another triangle, number 4. What type of triangle is this, Joshua? Scalene. This is a scalene triangle. Now if this does look like a right angle, but they didn't put a box there, so it might be just a little bit off 90, but it's a scalene triangle. So let's move on. I'm going to go ahead and read because I want to make this the video for the YouTube channel. What you'll learn: to classify polygons and special quadrilaterals. New vocabulary: quadrilateral, pentagon, hexagon, octagon, decagon, regular polygon, irregular polygon, trapezoid, parallelogram, rectangle, rhombus, and square. Why learn this? Artists and designers use quadrilaterals and other polygons in their work because these shapes are pleasing to the eye. A polygon is a closed plane figure with sides formed by 3 or more line segments. The sides meet only at their endpoints. You can classify polygons by their number of sides. So we already talked about one type of polygon. That's what you guys had your quiz over. It's a triangle. And a triangle is the smallest number of sides that you can have as a polygon. Got it? Okay. If you notice, the root word tri means 3. 3 sides, 3 angles. Quarter, if we think about a quarter, we're thinking about a fourth, or a quad 4. Quadrilateral is a 4-sided polygon. And then a pentagon, penta, that root word means 5, 5-sided polygon. Hexagon, hexa is the root word for 6, 6-sided polygon. Octa, root word for 8, 8-sided polygon. And deca, root word for 10, such as decade, 10-sided polygon. Now, what I need you guys to understand, and this is why I brought up that other word, equiangular, in addition to equilateral. Equilateral means the shape has all the same measured sides, right? Equiangular means the shape's interior angles are all the same angle. So a regular polygon, we already know about one regular polygon. It's the equilateral triangle. And the equilateral triangle has all congruent sides. So in order for you to be a regular polygon, 2 things have to happen. All the sides need to be congruent, and all the angles need to be congruent. So if I was to use those vocabulary words, regular polygon is a polygon with equilateral sides and equiangular angles. Does that make sense? Okay. An irregular polygon is a polygon with sides that are not all congruent or angles that are not all congruent. Okay? Now, it's not enough to have 1 or 2 sides congruent. Every single side needs to be congruent. Same with the angles. Every single angle needs to be the same angle in order for you to have a regular polygon. Okay? So this octagon clearly doesn't have any symmetry, but we've all seen a regular octagon. If you've seen a stop sign, you've seen a regular octagon, right? All the sides, you measure the sides of a stop sign, they will all be the same. All the angles are the same. This is an irregular octagon. All right, so let's go ahead and take a look at this. My first example. If you take a look at this first example, who can tell me what type of polygon I have and if it's regular or irregular? Somebody I haven't heard from yet. Henry, go ahead. Hexagon. This is hexagon, and what type of hexagon is it? Regular or irregular? It's regular because all the angles match. They're the same. And then all the sides have a measure of 2. Does that make sense? Now, if you look at this one over here, what shape do we have over here, Laura?
Pentagon?
This is a pentagon because it has how many sides? 5. It's a pentagon, and is it a regular pentagon or an irregular pentagon?
Irregular.
It's irregular because the length of the sides are all different. So does it matter what the angles are if the sides don't have the same length? Doesn't matter. If the sides don't have the same length, then it's automatically irregular. Okay, and we can already look at this, see the angles don't match either. Okay, now take a look at this one. This one's pretty interesting. Can somebody share with the class what type of polygon this is and whether or not it's regular or irregular? Somebody haven't heard from yet? Kayla, go ahead. Octagon, and it is an irregular octagon. And it's irregular because of why? Okay, right. We have these sides that are 2, and these 2 sides that are opposite each other are 7 and 3/10 centimeter. Okay, but all the angles are the same measure, correct? Okay, so you have to be both in order to be a regular polygon. Both the angles, all the angles have to be equiangular, and all the sides have to be equilateral. Okay, now what about this triangle over here? And I told you what it is. Is it regular or irregular? Regular. And we have a name for that. We already came across it. It's a what kind of triangle? Equilateral triangle. Okay, now let me ask you a question, because this relates to our portfolio project we did not too long ago. How do we find the perimeter of a regular polygon? There's 2 ways. Can somebody share with us one way? And then we'll talk about the other way. Can somebody share us one way that we calculate the perimeter of a regular polygon? Moyen, how do I calculate the perimeter of a regular polygon? Now, do you guys remember the perimeter is the distance around something, right? So if you think about the rim of a glass, it's the outer side of the glass. Around the glass would be the rim. Okay, so the perimeter is the measurement around a shape. So what would be the perimeter of, say, this triangle up here? What would be the perimeter? No, that's one side, right? The perimeter is the distance all the way around. 50? Are you sure about that? 15, yep. And how'd you come up with that answer? Tell me how you got that answer. Nice. You multiplied what? Nice. So that is one way to do it. If you multiply the length of a side times the number of sides, then you can calculate the perimeter of a regular polygon. Now, the other way to do it is how? Who's got another way to find the perimeter? How are you going to do it? Jason, say it again. Add the sides up. So the 2 ways to find the perimeter of not just the example I'm pointing to, but any regular polygon, you can add up the sides, 5 plus 5 plus 5, and we see that equals 15. Or we can use Moyen's technique, which is the number of sides times the length of one of the sides. That's going to give us 15 also. But this Moyen's technique is only going to work if it's a regular polygon. Do you guys understand? Okay, so that's what the question is asking. So keep in mind that if you're trying to find the perimeter of an object, wherever you start, you count the lengths of the sides and add them up until you got back to where you started. Are we good? Okay. Question?
So you said for Moyen's technique, we can only use if it's a
regular polygon, right?
What are we going to do for an irregular?
If it's irregular, you just would add up the sides all the way around. Okay? All right. So now, we learned about how to classify triangles, okay? We talked about classifying triangles based upon their sides and their angles, right? Now we're going to talk about classifying quadrilaterals. And a quadrilateral has how many sides? 4 sides, okay? So there's ways to classify quadrilaterals. The first way is a new way. We haven't talked about this. It's classifying them by how many parallel sides they have. And if you notice, I have some new markings in my drawing. Do you see the markings? They're not tally marks. What are those? I think the book calls them tick marks, tally marks, but these are called arrows. And so if you look, AB, segment AB, and segment CD, they both have an arrow on those line segments. That means those two line segments are parallel. Does that make sense? Okay, and so the definition of a trapezoid, only two sides of the quadrilateral are parallel. Got it? No more, no less if you're a trapezoid. Two sides are parallel. That's what makes you a trapezoid. The book kind of words it differently. They say one pair of sides. Well, a pair is how many? Two. So two sides are parallel in a trapezoid. That's okay. This only applies to quadrilaterals. Now, the other example, if you take a look here, they're not labeling each of the vertices, but they are labeling the sides that are parallel. Do you guys see that the horizontal lines have two arrows? Do you guys see that? This has two arrows on this side. This has two arrows on this side. That means those two sides are parallel because they have the two arrows on them. Do you understand? But the sides that are going up and down, they only have one arrow, so those two are parallel to each other. So do you guys understand the notation? Because sometimes they're going to use a combination of arcs, tally marks, and arrows to indicate the information about the picture. Do you understand? So I'm trying to get you guys familiar with this. So trapezoid has how many sides that are parallel? Two, or one pair. Parallelograms have how many sides that are parallel? All of them are parallel, but two pairs that are parallel to each other. Do you guys understand? So I try to color code this a little bit to show you guys what I'm talking about. All right, now, for parallelograms, there's a way to classify parallelograms, and here they are. And let me get you guys to look at something very carefully, because I feel like throughout the day some students were confusing some things. So there are three types of parallelograms, three special types of parallelograms. The first one's a rectangle, and look at the definition of a rectangle. All the angles are what? Right. All four angles of a rectangle, which is a parallelogram, are right angles. For a rhombus, that's another parallelogram. All four are what? All four sides are congruent. Now let's talk about the last parallelogram. It's a square. Now take a look. This has to be true, which is the condition or the definition of a rectangle. And this has to be true, which is the definition of a rhombus. So now I want to talk to you guys about something, because you're going to see questions like this where they're going to try to word it and throw you off. So is every rectangle a square? No. But is every square a rectangle? Yes. Is every rhombus a square? No. No. But is every square a rhombus? Yes. So look, here's the condition, and that's why I color-coded the way I did. For you to be a square, you have to have both conditions have to apply. All your angles have to be 90 degrees, which is what a rectangle is. A rectangle says nothing about the sides. It just says, hey, you got four 90-degree angles. Got it? You're a quadrilateral with four 90-degree angles. That's what a rectangle is. Okay? A square, in addition to that characteristic, the sides also have to be the same length. Got it? So a rhombus, it doesn't care about the angles. It just cares about the length of the sides. All the sides are congruent. Do you understand? It doesn't matter what the angles are. But there is one circumstance where a rhombus and a square are the same, and that's where the angles are 90 degrees. Got it? Okay. Any questions about that? All right. Let's move along. All right, architecture, classifying polygons. So architecture, use the best names to identify the polygons in the window shown at the right. So we have this window, and let's just identify a few shapes because you're going to see a question like this in Connexus in one of the quizzes or tests. So what shapes do we see in this window that we've talked about so far? Jason?
Octagon, square, rectangle.
So just give me one at a time. So you see an octagon. Good. Okay. And somebody give me another one. Trinity? A square right in the middle, right? What other shape haven't we brought up that we can see in this? Moyen?
Triangle.
A triangle, very good. Here's a triangle. Okay, what other shape? And there's more, there might be another triangle that you see. I'm just drawing in one triangle. Okay, Adipoju, what's another shape you see? Very good. We have a rectangle. So I'll draw in this rectangle. Okay. Do you see another shape that we haven't mentioned yet? Dominic? Yeah, there's more than one rectangle. I'm just doing one rectangle. But do you see a different shape that we haven't brought up yet?
Did they already mention that there was a trapezoid up there?
Yes, there is a trapezoid. So let's take a look. I'll highlight a trapezoid. Here's a trapezoid right here. Boom. There's other trapezoids, but that's one trapezoid. Do we have another shape that we haven't brought up yet? We already brought up the octagon. How about a pentagon? Take a look at this pentagon. 1, 2, 3, 4, 5. That's a pentagon, right? Okay. Isn't that 5? 1, 2, 3, 4, 5 sides, so it's a pentagon. Lola.
I think so. Is that
Okay, I don't want to spend too much more time on this. Just understand the question. You will see a question very similar to this later. Okay, give me 3 shapes in this first picture, painting, whatever it is, in this pattern. Okay, Nathan. Triangle. You see a triangle? Here's a triangle. And you better not say the Triforce of Zelda, because that's not a triangle.
I was just thinking.
I might give you 1 point out of 3 just for some nostalgia, for the sake of nostalgia, but that is a triangle. It's not the Triforce. Who's got another shape in here? Somebody I haven't heard from. Go ahead, Joshua. You see a hexagon. I see a hexagon too. Unisa, can you give me one more shape? You got one more for me? Can somebody help out Anissa?
I know what it's called.
Taylor?
Picture itself is a square.
Yeah, they want to talk about the pattern though, so find something in the pattern.
So specific.
Jeremy, can you help her out? We do have a couple trapezoids. Watch, here's one.
There's one over. That one. The one at the
Where
top
was the
at the bottom.
bottom?
There's a few, right. You might have noticed that there's a pentagon in here, if you want to consider the edges. But all right, how about this one over here, the next picture? Give me a couple. Can somebody give me one? Jayla, give me one. You see a rectangle? What, you talking about the big rectangle? In the pattern, though. What do you see in the pattern? A rhombus. Yeah, there's a rhombus in here. That's a rhombus. What else do we have? Who's got another one? Talise? A square. We got a square in here, right? What else do we got? Lola? We got a triangle, right? Okay, I'm going to move along because I feel like this next one's more important. So pretty much every single class I've had today remembers using geoboards. You guys remember using that? And then on the geoboard, you would usually take and stretch out your rubber band and make the shape. Okay, well that's that's basically the same function of the dot paper. And let's go ahead and answer this first question. See if you could, on your piece of paper, draw a parallelogram that is not a rectangle nor a rhombus. Can you draw a parallelogram that is neither a rectangle nor a rhombus? And if you have it, I would like to see it, and I'll draw something similar on the board. Who wants to share their parallelogram that's not a rhombus or a rectangle? Go ahead. Show it to me. Octagon's not a parallelogram. Parallelogram, we were talking about quadrilaterals. Four-sided figures. Can you show me yours? Just hold it up so I can look at it. Nice. That's exactly what you have to do. So watch this. Here is a parallelogram, and I'm going to draw what sides are parallel. Okay. So that's this one right here. If you notice, and I'm going to use some of the notation that I've been trying to teach you guys. These two sides are congruent, right? Okay, and in order to be a parallelogram, you have to have two sets of sides that are parallel. So I'm going to put an arrow over here, and I'm going to have to put two over here to show that these two sides that are opposite are parallel. Do you guys see how we're using notation? So that's the first one. Now, can somebody show me a rhombus that's not a square? A rhombus that's not a square. What's the definition of a rhombus? Do you guys remember? What's the definition of a rhombus? Isn't that a dance? A rhombus? A rhomba? What's the definition of a rhombus? Four congruent sides, right? So I'm just going to show you a rhombus. This one's pretty easy. So watch. And I'm going to draw this using some of the technology. Take a look at this. Shh. Here's my one side, right? And in order for us to be a rhombus, we have to have how many congruent sides? Four congruent sides, right? How many sides need to be congruent for us to be a rhombus? Four. So here we go. All these are the same length. Okay, so if you look, this side is congruent to this side, and these sides are also congruent to the other two sides. So that's a rhombus. It's not a square. Okay, and then lastly, we need to draw a trapezoid with a pair of congruent opposite sides. Be careful how you interpret this. If you interpret what it's saying, telling you to do, you're going to have a hard time getting the correct result. Trapezoid with a pair of congruent opposite sides. Yep. Nice. So if you assume that the parallel sides are the congruent sides, you can't draw a trapezoid that way. Not the way they're describing. Right? Because if your parallel sides are congruent, then no matter what, you end up with a parallelogram. So to make it work, if you draw a trapezoid where the sides that are congruent are the sides that are not parallel, then what you have is the result you want. That's congruent to that. This is not congruent to this. Okay, however, this is parallel to that. Okay? Are you guys getting familiar with the notation now? Okay. Okay, we're at the end of our lesson. How do parallelograms and trapezoids differ? Who can explain that to the class? How are they different? How are parallelograms and trapezoids different? Kayla.
Parallelograms, both sides are parallel, but in trapezoids,
Okay, when you say both sides, you're saying two sides are parallel?
no, like all of the sides.
You know what you're trying to say? You're trying to say the opposite sides are parallel. Okay, the opposite sides as a set are parallel. So you have two pairs of sides that are parallel. Okay, and what about a trapezoid? You only have one pair of sides that are parallel. So here it is, worded a little bit kind of polishing off what you just said. Okay. Parallelograms have two pairs of parallel sides. That should be an S. I'll put an S after the fact. Sides. And trapezoids have only one pair of parallel sides. Okay. Can you draw a square that's not a rhombus? Remember we said this? No, because why? Squares have congruent, all sides are congruent, right? That's by definition what a rhombus is. So every square is a rhombus, so it's impossible for you to draw a square that's not a rhombus. Are we good? Okay, list all the names that apply to each of these figures. Dominic, you have a question?
Well, I have a comment. So, if a square isn't a rhombus, then it's not a square.
No. Right, exactly. If he said that a square, every square is a rhombus. So if you have I mean, what you're saying kind of is a contradiction. If a square is not a rhombus, then it's not a square. You're already kind of like contradicting yourself right there. Every square is a rhombus. Okay. All right. So this first picture over here, who can tell me what type of shape this is? What's one? This is a what? It's a parallelogram. What else is it? One at a time, please. Joshua, what is it? It is a quadrilateral, 4 sides, so it's a parallelogram, a quadrilateral. What else is it? Think about some of the definitions we came up at the start. It's not a rectangle because there's no degrees in there that are 90. And they're different measures. They all have to be 90 for that to be a rectangle. What else? Think about the first definitions I went over with you. You got it? Nice, nice. So not only is it a quadrilateral and a parallelogram, it also is an irregular polygon. Okay, this one over here, what shape do we have over here? The middle one. Who can answer this one? Somebody, Kalila, what kind of shape do we have here? It's irregular, but what kind of what is it? Irregular what? What? That's not a rhombus. A rhombus has 4 congruent sides. None of the sides are equal, right? So it's irregular, isn't that what you just said? But what type of shape is this? How many sides does it have? So what do we call a 4-sided polygon? Nope. 4-sided polygon. If I had 4 coins to make up a dollar, what kind of coin would I have? Quarter, Q, U. Quadrilateral. So a quadrilateral, and it's a regular polygon. Over here, this has many names. Can somebody give me a name? A rhombus, yep. It is also a rectangle. What else is it? Quadrilateral, what else? Square, what else? Regular polygon, good. There we go. A lot of them. A lot of the